In this problem, we are ordered to give 3/4 strength isosource tube feeding at 60 milliliters per hour. We need to prepare and then hang 500 milliliters. How many milliliters of the full strength isosource do we need? And then also connected to that, how many milliliters of the water do we need? The key here is to understand what information we're given and how that's relevant to the solution. And a lot of these problems, as you've probably already noticed, many times you're given more information than you need. In this problem, we are asked to prepare, and we're preparing to hang 500 milliliters of some sort of solution. That solution needs to be 3/4 strength. 3/4 of that solution needs to be isosource. So I have already gone ahead and just quickly drawn a bag, 500 milliliters. And what I know about this particular volume here, we're just going to assume that it's full. What I know is 3/4 of this solution, here's 3/4. 3/4 of this solution is going to be the isosource. So we need to have 3/4 of the isosource. And then if I change colors here, let's change colors to green. 1/4 is going to be water. That's what we're going to dilute it with. 1/4 of water. Whoops, if I can spell water. There we go. So we need to figure out 500 milliliters. 1/4 of it's going to be water. 3/4 quarters of it is going to be isosource. So if I can just figure out 3/4 of 500 milliliters. If I can figure out what this 3/4 of 500 milliliters is, then I'll figure out how much of the full strength isosource I need. Remember when we talked about multiplication? If we take this expression, 3/4 of 500 milliliters, I can write that using mathematical notation. 3/4, and if we want 3/4 of is telling us to multiply. 3/4 of 500 milliliters. So I'm not going to include the milliliters. I'm just going to write 3/4 of 500. Now if you take our calculators and we do 3/4 times 500, whoops, you get 375. So that's telling us that 375 milliliters of the isosource is going to be this part. Of the total 500 milliliters, 3/4 of that, in this case 375 milliliters, is that full strength isosource. So what is going to be this next part here? If 3/4 of it, or 375, is isosource, well, if I take that, I know the remaining 500 milliliters. If I subtract away that 375 milliliters, I'll get the difference. I'll know how much is going to need to be water. And if you subtract that, you get 125 milliliters. And this is of water. Again, we know of the total volume is 500. If it's 3/4 strength, that means 3/4 of it is going to be made up of the isosource. So we need 3/4 of 500, or the total. Of symbolizes multiplication, so 0.75 or 3/4 times 500 gave us 375 milliliters. Of that remaining part, we needed to figure out, well, if 375 is the isosource, well, the remaining part is going to be water. The remaining part is 1/4. So if we take 500 and eliminate the 375 that represents the isosource, we're left with 125. I will say you can check your work as well. Right? We could also follow along here. 1/4 of 500 is water. So if we take 1/4 of 500, so if I just write that out, 1/4 of 500, that would be 1/4 times 500. If you multiply that, you should get 125. So that was just a little check. That's not how we originally solved it. We originally solved it by taking away 3/4, but you can still do that, right? Just as we took 3/4 times 500, we could also take 1/4 times 500. Notice both of these methods will allow us to get the correct solution of 375 milliliters of isosource and 125 milliliters of water.